Hello friends, I'm Dr. Bhavna Thakur and I teach digital time signal processing at the undergraduate level. I have often found that students find the topic of circular convolution a bit difficult to understand, and therefore I thought of uploading this video for all of you. Basically in this video I'm going to explain the concept of circular convolution and how to find the circular convolution of two sequences in the time domain. So let's start. Now, uh, all of you know that the circular convolution yc of n is equal to x of n circular convolution with h of n. Now, this c stands for, subscript c stands for circular convolution. And in linear convolution, we have asterisk sign over here, but this is replaced with this symbol over here, showing the circular convolution. Now, by definition, the circular convolution of two sequences x of n with h of n is given by this equation summation of m equal to 0 to n minus 1 x of m into h of n minus m modulo n. Okay. So let's straight away start by finding the circular convolution of given two 4-point sequences x of n which is equal to 0, 1, 2, 3 and h of n which is equal to 2, 1, 1, 2. Now the symbol over here is denoting this is the n equal to 0th sample, and here also this is the n equal to 0th sample is equal to 2. Okay. So we need to find the circular convolution of the above sequences, and as we can see the length of this sequence is equal to 4. Now the length is denoted by the capital letter n, okay, and which is equal to 4. You must also be aware that in circular convolution, the length of the two sequences has to be necessarily same. Okay, unlike the linear convolution where the two sequences length can be different or can be arbitrary. So in circular convolution, it is important that the length of the two sequences should be same. Now, how to find out the circular convolution? Now, this is going to see the definition, and we are going to, from this definition itself, we are going to find out the circular convolution. Now, first, what we do is we find out, we change the index of the two sequences, that is from from n to m. Okay, so we change the index of the two sequences to get x of m and h of m. Since you can see over here, this index has changed to m, and here also index has changed to m. Okay, and after that you can see that this h of m has been folded, so it will become h of minus m. So in the second step, what we will do is we will fold the sequence h of n, and we'll get h of minus n. Okay, and this is done by using the time reversal property. Okay, and after we get h of n minus m, h of minus m, sorry, we need to shift it or rotate it, circular shift it, and so that we get the values of h of n minus m. So after doing circular shifting, we will multiply for each value of n, we will multiply sample by sample x of m with h of n minus m. Okay. So this we are going to do for all the values of n, and the range of n over here will be n equal to 0 to capital N minus 1. Okay. And after that, we get all the output values of yc of n. Okay. So even if it is not clear over here, we shall solve this particular example and it shall be clear to you. So I've taken the same sequence which I've shown in the previous slide. X of n is equal to 0, 1, 2, 3 and h of n is equal to 2, 1, 1, 2. Okay. And like I told you in the first step, you have to change the index from n to m. So we are doing this by a tabular sort of method. Okay, so in the first row, what we'll do in the table, we'll write m, and we will write 0, 1, 2, 3. So why 0, 1, 2, 3? Because the range of m is equal to 0 to capital N minus 1, and capital N is equal to 4 over here. So m is equal to 0, 1, 2, 3, right? So we will write m is equal to 0, 1, 2, 3, and then below that we are going to write x of m. So what is x of m? X of m is equal to 0, 1, 2, 3, since you have changed the index from n to m. So x of m is equal to 0, 1, 2, 3. And similarly, we will write h of m also, which is equal to 2, 1, 1, 2. Okay. So now, like I told you, in the first step, we have already done the first step, that is changing the index from n to m. And then in the second step, we have to find out h of minus m. Okay. Like I told you, how is h of m minus done? This is nothing but your using the time reversal property. Okay, in the time reversal property, all of you know that this 2 will remain as it is, and since if I reverse this m, if I take h of minus m is equal to say 3, then this will become h of minus 3. But this is not in my range of vision. My range of vision is only from 0 to 3. Okay, so what I have to do? I have to use the modulo 4 over here. And what is modulo 4? Modulo 4 brings us from the, if you are out of range, it will bring us in the range of vision over here. That is, this modulo 4 is nothing but h of 4 minus m. So h of minus m modulo 4 is nothing but h of 4 minus m. Okay, we'll see how to find out this. So h of, let's come back over here. So in the first point will remain 2, that is 2 will come over here as it is. Okay, and in the next step what we'll do is we have to find out for m equal to 1. So this, for m equal to 1, this will become h of minus 1 modulo 4. So what is h of minus 1 modulo 4? It is nothing but h of 4 minus m. That is, what is m over here? M is equal to 1 over here. So what is 4 minus 1? 4 minus 1 is equal to 3. So h of minus 1 is equal to h of 3. So h of 3 is what? H of 3 is equal to 2. So what we will get over here? This 2 will be brought over here. Okay. So let's take this second sample point again. Now this again here we have m equal to 2. So if m is equal to 2, then this will become h of minus 2 modulo 4. So what is h of minus 2 modulo 4? That is nothing but h of 4 minus 2. And what is 4 minus 2? 2. So h of minus 2 is equal to nothing but h of 2. And what is h of 2? H of 2 is 1. So h of 2 is 1. That means this 1 will come as it is over here. Right? Now let's take the last sample point, that is h of minus 3. So h of minus 3 modulo 4 is nothing but h of 4 minus 3. So h of 4 minus 3 is nothing but h of 1. That means what will happen? This h of 1 value, that is equal to 1, will come over here, and this will be equal to 1. Okay. So h of minus m4 is equal to 2, 2, 1, 1. Okay. Now let's find out for n equal to 0. Okay. So for n equal to 0, that means we are finding out first for n equal to 0, that means yc of 0 is equal to, yc of 0 is equal to x of m into h of n minus m modulo 4. Okay. So yc of 0 is equal to, now we multiply sample by sample. So x of m multiplied by n equal to 0, that means this will become h of minus m4. Okay. So this will become x of 0 into h of minus m4. So you have to multiply sample by sample. So first see this x of m multiply by h of minus m4. So you will multiply 0 with 2. Okay. And then you will multiply 1 with 2. Again multiply 2 with 1, and again multiply 3 with 2. And since there is a summation sign, what we do is we add all these product values. And what we'll get is 7. Okay. So again what we'll do is we'll find out for yc of n equal to, now we'll find yc for 1 value. Okay. So we'll find yc of 1. So yc of 1 is equal to nothing but m equal to 0 to n minus 1 x of n into n. So what is n over here now? N is equal to 1 now. Since we are finding out, we have already found out for 0, we have to find out for 1 now. So this will become h of 1 minus m modulo 4. Okay. So again, h of 1 minus m is nothing but what you're doing, you're circularly shifting this sequence to the right by 1. Okay. So if I shift this sequence to the right by 1, this 2 will come over here. Again, this 2 will come over here to the right, and this 1 will come over here again to the right, shifted by 1 value to the right. So this 1 will come over here, and there's a vacant place over here. Therefore, this 1 will be circularly shifted, and this will take this vacant place over here, and what we'll get is 1 over here. Okay, so 1 minus m is nothing but you're circularly shifting or rotating this sequence by one position to the right. Okay, so 2 will come over here, 2 will come over here, this 1 will come over here, and this 1 will be taking this vacant place over here. So by circularly rotating, it will come back over here. Okay, this is like musical chairs we play. Again, what we get is we have to find out for yc equal to n equal to 1 now. We have already found out for n equal to 0. Now we are finding out for yc. So put n equal to 1 over here. So what you will get yc 1 is equal to x of m into and n is equal to 1. So this is x of m multiplied by h of 1 minus m modulo 4. Okay. So again, we have to multiply x of m, but now we are going to multiply with h of 1 minus m, okay, not of h of minus m. So you are going to multiply this sample with this sample, okay. So what we will get, sorry, this yellow over here, so 0 multiplied with 1. So again, 1 multiplied with 2, 2 multiplied with 2, and 3 multiplied with 1, okay. So what we'll get over here is 0 into 1, 1 into 2, 2 into 2, and 3 into 1. And since there is a summation sign over here, we have to add all these values. Okay. Again, we have to find out for yc is equal to, for n equal to 2. And this we'll find out up till 3 because n is equal to 0 to 3. So we'll find out for n equal to 2. So yc of 2 means it will become, you will get yc of 2 and x of m, h of this will become 2 minus m modulo 4. So again, we know already know x of m, we have to just find out h of 2 minus m. So h of 2 minus m is nothing but again you have to circularly shift this h of 1 minus m to the right, to the right. So what will get, this 1 will get shifted to the right over here. Again this 2 will get shifted to the right by one sample and we'll get 2 in this position. Again this 2 will again get shifted to the right over here and you will get 2 in this position and this 1 will take this vacant place over here by rotating and coming back over here and taking this vacant position. So what is h of 2 minus m? This is equal to 1, 1, 2, 2. Again we can find out yc of 2 which is equal to nothing but you are multiplying x of m with h of n minus m. So what is x of m? You have to multiply 0 with 1, 1 with 1, and again 2 with 2, and 3 with 2. Okay, and then what you do is you add all these values since there's a summation sign and you'll get yc of 2 which is equal to 11. Okay, again what we'll do is we'll find out the last value that is h3 minus m which is nothing but again we have to shift this h of 2 minus m to the right, one value to the right. So we'll get 1 over here. Again, we'll get 1 over here because circle is shifted to the right by one sample. Again, we'll get 2, position will come over here and this 2 will take this position over here, vacant position over here. So we'll get h3 minus m is equal to 2, 1, 1, 2. So again, we'll multiply sample by sample. That is, we'll multiply 0 with 2, 1 with 1, 2 with 2, and 3 with 2. And then we're going to add all these values. So we'll get y3 of 9 is equal to 9. So finally, yc of n is equal to 7, 9, 11, 9. I hope this concept is now clear to you how to find out the circular convolution of two sequences. Now this I have explained in time domain. You can also find out the circular convolution in the frequency domain by finding out the DFT of the two sequences and multiplying it and then taking the inverse DFT. If you want a video on that, kindly let me know in the comment section. Yeah, and if you want any other videos based on in this area, you can write down in the comment section. I will upload it for you. Okay. Thank you very much.